In this video, we're going to present the definite integral. And I'm following the textbook here, even though the textbook does present this material in a slightly unusual order. I mean, the material is all correct. It's all stuff that you would learn in any calculus class. Often you would not learn it in quite this way. But I am following the textbook since, I'm having you read it. It's our major learning resource for this class. So, the definite integral of a function lowercase f of x on an interval from A to B. The definite integral is written like the indefinite integral with one exception. So the integral symbol f of x dx. The exception is that the start of this interval gets written here at the bottom of the integral symbol, and the end of the interval gets written up here. The textbook defines the definite integral to be capital F of B minus capital F of A, where capital F is an antiderivative of lower case f. What could this possibly be good for? Well, suppose you have a moving object. Let's say the object is moving strictly from the left to the right, just to simplify things a little. So it's got a positive velocity. And we have a velocity function v of t on an interval from A to B. And we ask the question, how far does the object travel? We should be able to answer that question, right? If we know how fast the object moves, we should be able to figure out how far it goes. Well, if it starts at S of B and it ends at S of A, the distance it travels is just its end position minus its beginning position, right? I mean, if the object starts at 2 and it ends at 5, then how many units of distance did it travel? 5 minus 2 equals 3 units of distance. Now, S is an antiderivative of v. Velocity is the derivative of the position, so the position is the antiderivative of the velocity. So this question I asked, how far does the object travel? It's s of b minus s of a. And considering that s is an antiderivative of v, this is precisely the definite integral from a to b of v of t dt. So we use the definite integral when we want to measure change. Here, the definite integral is telling us how far the object physically moved. It's measuring physical change. But of course, there are a lot of examples where we want to know how much is a function going to change? How much are profits going to change? How much is the pollutant in a lake going to change? Questions like that are the domain of the definite integral.